In this video, we're looking at the graphs and key features of sine and cosine. I already have this down, this graph of sine and cosine. This would be August 30th and August 31st, based off of what we did for the homework. So if you don't already have this, you need to click on the previous link, go to the previous page, and print off this and go through those two videos. They explain how we got these graphs. But once we had these graphs in class on August 30th and August 31st, what we did is we looked at these functions and said, well, now that we have this function, and by the way, this is f of x equals sine x. Now that we have these functions, what makes them unique? So at the bottom of the page, I have students write, this here, that was the question that I left off at the bottom. What is making this function unique? So in pre-cal, we're going to come across multiple different functions. And when we come across those functions, what we really want to do is say, hey, I notice it's different than another function. What is going to make, what makes this different? And so in class, students had time to look at the function, look at their own, and look with their partner, like what makes this function unique? And what stood out, I'm going to kind of summarize. You can take, if you want to pause, take notes as we go, that's fine, in the space on here. I'm not going to write that. We did that in class. I'm just going to kind of talk about it and do, show with my fingers what we talked about. And then I'm going to write the key pieces down. But one thing that students said is that the function, if we continue going in both directions, like here, this function is going to continue going on forever in this direction, and it's going to continue going on forever in that direction. So we're really talking about the x values here, and because we're looking at along the x-axis, and if we're talking about the x values, then we're talking about the domain of the function. Put the x there. Excuse me. And if we're talking about domain, then we'll also talk about the range, which is the y values that the function can take. And here, we said the domain, we start with our lowest value. So if I look all the way furthest left, how far left can the function go? Well, it can go to the left forever. And so if it goes to the left forever, we say that would be negative infinity. And it continues going like this, and it goes on forever in the right-hand direction. So because it goes forever in the right-hand direction, we say it's going to go towards infinity. So our domain, what this is telling us is that if we look at the x values that the function can actually take, they take all of them. They go from negative infinity to infinity. So that's our domain. Similarly, a lot of students said, well, I noticed that if I'm looking at the y-axis, the lowest value can go to is -1, and the highest value can go to is 1. And that is true. So even here, as this continues to go on forever towards infinity, this function is going to go up. It's going to go up to 1, and then it's going to come down through 0, down to -1. And then back up to 1, and then it's going to do that forever. It's called oscillating. And so because it does that, here we say that the lowest value the function takes is -1. The highest value the function takes is 1, and everything in between. So that would be our range. Now with this, we need like parentheses or brackets around these to actually denote the interval. Now I'm going to put this note up here. If we have a parentheses in an interval notation, what the parentheses is telling us is that we do not touch. It does not touch that value. And I'll explain here in a second. And if it's a hard bracket or just a bracket, that means it does touch. It's going to actually go to and touch that value. So when we're talking about the domain, we're talking about the function going towards negative infinity. It's going to go forever. We could get really close to it. We can't really get close to infinity. We don't know what infinity is. We can't touch it. So because we can't touch negative infinity, Here we put a parentheses. Same thing with infinity. We're going to put parentheses because we can't touch those. Wow. Can't touch those, not even values, those ideas. We can't even touch infinity. If we look at -1, if we're looking at the range, well, notice the function goes down and actually does touch at -1. So I'll put a bracket there because it does touch at -1. Same thing with +1. It does touch at +1. So those would be our domain and range. That's why we use a hard bracket around -1 and 1. All right, so that's our domain and range. Now, if we want to talk about other things, another thing that students brought up is that it has a wave shape. And there's two things that we can talk about here. It would be great if we can actually measure the wave, and we can, doing that in a couple different ways. First is measuring like what some people said is the crest and the trough of the wave. So what we can do is measure the distance from the middle of our function, in this case the x-axis, the middle of the function to the top of the wave, and the middle of the function to the bottom of the wave. This distance here, 0 to 1, that's going to be 1. This distance here, 0 to -1, but remember that distance cannot be negative, so this would be 1 as well. And what we call this distance, if we're talking about a wave, we call this the amplitude. So we say that this function's amplitude is 1. And another thing we talk about with the wave shape is that, notice here, I go up, I go down, I go up, I go down, I'm going to go up, I'm going to go down. So the function repeats itself. Now, because it repeats itself, we can actually measure how often it repeats itself. Or in other words, like, is it going to repeat itself after pi units, after 2 pi units? We can figure this out. And we can do this, what we did in class is started here at 0, 0, and just trace the function and figured out, all right, what point is the function actually going to repeat? And here we start at 0, 0, we're going to go up, down, we get back to 0, but we're not going back up. We are still going down, so the function continues to decrease, 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 increase, increase, back at 0. Now, if I were to copy, like take a look, copy and paste, then that's going to be the exact same thing. I'm going to go up, I'm going to do this exact same shape here. So we said that it's going to repeat here at 2 pi, and if it's repeating, how often it repeats, we call that the function's period. So the sine function has a period of 2 pi. So these are our 4 main key features that we're going to focus on in this class. There are others for sine, but we're going to mainly stay with these 4. Now, one more thing I want to mention, and then I'm going to go to start the next video for cosine, is that some students mentioned, hey, sine goes through 0, 0. So sine of x, what people said, starts at 0, 0. And that will be helpful, hopefully as we see in the next video and moving forward. What I would recommend, pause, rewind if you need to, what I would recommend is go to the backside, see if you can figure out, the domain, range, amplitude, period for the cosine function. See if you notice any similarities or differences, and then in the next video, I'm going to just, describe the key features and also the similarities and differences between the sine and cosine function.